Okay, so today we're going to talk about imaginary numbers. And the nice part about imaginary numbers is they're pretty easy to wrap your head around them after you understand just a couple of things. So last week we talked about the square root of negative 81 being 9i. And the reason we said that was 9i is, well, we can't really take the square root of negative 81, but we can take the square root of 81. Call that 9. And then when we take the square root of negative 1, we say we can't do that, so we'll just say that that is this variable that we call I. So it's pretty simple to do those kind of things. So then let's see, once we start doing other kinds of things, like trying to add different numbers. So let's say we were given this. So if I was given this, the first thing that I'm going to do is I'm going to simplify everything that I can, which then I'm going to have 5 times 4i plus 3i. Well, 5 times 4 is 20. And then 20 plus 3 is 23. And as you notice, I just keep the i's along. So what we want to do is we want to treat I like a variable and just kind of keep them along. Let's see another example. So let's say we were given 20 plus radical negative 9 plus 2 radical negative 25. So let's say we're given this. Well, first thing I'm going to do, again, is I'm going to simplify these things. So square root of negative 9 is 3i. And then have 2 times 5i. Well, 2 times 5i would be 10i. Now we have to think about adding. I can't add 20 and 3i because they don't have the same terms. Like they don't have a variable. So you can't add the things. But I can add 3i and 10i, so I can do that. So when we do that, we would get 20 plus 13i. So again, a lot of times we're just going to treat I like a variable, and we're going to use it like a variable, and it makes it pretty easy. Let's scroll down here and look at something else. Let's say I was given something like 5 plus 2i squared. The first thing that I'm going to do if I'm given 5 plus 2i squared is I'm going to rewrite it like it should be, which is these two things times each other. And then I'm just going to kind of go through and FOIL, or double distribute, whatever you want to call it. 5 times 5 gives you 25. 5 times 2i will give me 10i. That will give me 10i, and this will give me 4i squared. Okay, so again, it works just like x's. Now we're going to combine some like terms. So 25 plus 20i plus 4i squared. This is the only step that is going to be different than how we treat a normal variable. It's when we get this I squared. Now, if you think off to the side, I squared would really be the square root of negative 1 squared, because that's what we called I. And then a square and a square root cancel each other. So I should be negative 1. Well, if I is negative 1, that makes it pretty easy, because then I can go 25 plus 20i minus 4. Because I is negative 1, so if you plug that in, negative 1 times 4 gives you negative 4. I squared will just switch the signs of your term that you have. Then we can combine it a little bit further, which means that you'll have 21 plus 20i. the reason we care about these i's so much is because now I can solve a problem that looks like this. Where before we couldn't. Now we can subtract 81. And then take the square root of both sides, and I can go, oh, x is going to equal 9i and negative 9i. So try some of these problems today. Make sure, again, the biggest thing is treat I as a variable. If you treat I as a variable, everything goes pretty well. So we can combine like terms, but we can't combine like this 20 and this 3i. Okay? So let me know if you have any questions.